Alright, so the usage of the tires would be updated accordingly. Like it's up to you if you can, if you want to set the mileage exactly equal to the usage. Okay? It depends. Okay? The basic idea behind is that the car object should be sending, like updating the tire usage. In other words, sending a message to the tire objects, to each of the tire objects, because we have an array. So each of the active tires, like the apart from the spare tires, okay? So each of the tires should be sending and updating the usage attribute of the tires. Okay? Each like the car object should be updating the usage attribute of each of its tires. So this is basic idea. So like for this, the car the move method, the car, I'll give you a hint. The car move method should firstly increment its own use mileage. Okay? It should access and increment its own mileage. Secondly, it should increment the usage. It should call that each tires increment usage method, which should simply um, like increment the current usage, okay, or whatever. You can also like change the parameters of this increment usage method if you want to send the mileage value or any other value, okay. So you can increment the usage, so you can update the current usage by a particular value. So increment usage method is up to you. It's up to your imagination, your innovation, how you want to implement that. But the basic idea behind this is that the car move should be calling the increment usage method for each tire. Okay, this is important. Similarly, we've talked about set info. Okay, that is being called from the main and so on. Okay, sure. Let's move forward. So this should be the main. You should not be changing the main function. And obviously, for each class, we have to separate the interface and implementation. So we have one file for the car header file, which has the definition of the car class, and the implementation of the car class should be in car.cpp. Similarly, tire.h should include the definition of the class tire, and the tire classes implementation should be in tire.cpp. And then we should have a fifth file, which is, for example, car driver or car client.cpp, which should include this main. All right, let's move forward. Let's talk about composition. Okay, the strongest of all relationship is composition. Okay, in this case, both the lifetime also are related, strongly related of each object, and the ownership is also very strong. Okay, so there's an ownership relationship between the two classes or between the two objects of each class, and secondly, the lifetime is also depending. The lifetime of the components is depending on the lifetime of the composite object. For example, the parent object, the life of the child objects is depending on the lifetime of the parent objects. Okay. So let's read out the definition first. Composition is a special case of aggregation. Okay. It's similar to aggregation. In aggregation also we had this ownership relationship, but the lifetime was separate. In this case, the lifetime is dependent. The lifetime of the child objects is dependent on the lifetime of the parent objects. So uh, this is another restriction or another constraint which is being added in composition. When object contains another object, if the contained object cannot exist without the existence of the container, then it's called composition. Okay? So here we are discussing a case. For example, the company contains employees. The employee is basically a term which is related to a company. Okay? Company has employees. Okay? That person might exist, but with respect to the company or in context of the company, the employee will not exist if the company does not exist. Okay? So a company gets destroyed or deleted, then employee should also be destroyed. That person might exist and that person might become an employee of another company, but the employee entity or employee um, in the context of this scenario, the employee will not exist. Okay. So there exists composition between company and employees, since an employee cannot exist without a company, because the term employee is basically related to a company, okay, or an organization. Similarly, a car engine is also part of a car. So this relationship is also called like has a relationship, or if you're talking uh, in terms of from the perspective of the child object or the component class, then we can say it's that component is part of the composite class. Um, and so when the car is destroyed, the engine is also destroyed. So engine and car example. Okay, the car has some attributes and similar attributes which we discussed in the previous example aggregation, in which we have tire we had which in which we had tires. So engine, all right. So engine, let's assume this engine is only restricted to this car. If the we cannot like we cannot separate the engine and use this engine in another car. If that was the case, then that would have been aggregation. Okay. So here the lifetime of the engine is depending on the lifetime of the car. So it's simply an object which is defined. There is no pointer. It would contain the actual object. They can not a pointer or a reference to another object. The engine can have its power attributes such as power, okay, and horsepower, which is basically and started a boolean called started, that engine is started or not. So the start will set the boolean to true. The started to true. Stop will set started to false simply. You can also display a message as well. Similarly, this car should have a parameterized constructor which should include the engine, and we should include the engine, and the engine value must be set uh, using like either through the initializer list or whatever in the definition. Okay, you can also print the information of the car. The car start function, again an important concept. This is important. The car start method should actually be starting the engine. So this should include a function method call or a function call of the engine's start. Okay, the car ka start definition must include something like engine dot start. Okay, similarly, the car dot stop should include the car stop method should include engine dot stop. Okay, so this is important. The message passing. Okay, this should be very clear. Is started is simply a Boolean function which would return whether the car is started or not, and the car itself, uh, the status of the car is not is basically not separate. It's depending upon the status of the engine. So here would we would the definition of is started might include something like return engine dot started. Okay, and we can have setters and get you, and we didn't have space to write the setters and getters, so you can have a getter for started of the engine, and that getter would be called in this uh, function definition of is started. So is started might include something like return engine dot get started. Okay. So this is how we represent this in class diagram, that we have this solid or a black diamond, solid diamond. Let's look at aggregation. We missed that. Aggregation is basically a hollow diamond or a white diamond. And these diamonds are should be with should be drawn with the should be joined with the or should be drawn with the uh, like parent object or object class, or simply the composite object as composite class. Okay. Similarly, in association, there is no such no there's since there is no parent child or a composite component relationship, so there is no diamond in association. All right, so let's get back. So here also, if we have given the main function and you have to implement this again, there will be 5 files: car.h car.cpp, engine.h engine.cpp, and we'll include this in the main, and the main would be, for example, car driver or car client. Okay. You can continue on the anyways, or it's better to make separate files. This should be a separate example, not a continuation of the previous example. Okay, you have to create another separate files, separate submissions for this. So now let's see what this main function does. It initializes the engine. The horsepower of the engine is basically the argument. You have to create a parameterized constructor for that. And since it's a constant, so it should be initialized or set in the initializer list. Okay. So this is also important. You should be setting this in the initializer list of this parameterized constructor. The car Corvette Coupe creates a car, the engine is passed, and the car.start would simply set the relevant parameters as discussed earlier, and simply this message would be displayed if the car is started. You get this. So this is how the is started method is being used. So just try to check that. All right, a summary about association, aggregation, and composition. Association is the relationship. All right, so we've discussed this in detail, so you can have a read on this. So what next? This is part B. You get the part B. Yeah, for the example in which only the class diagram is given and the main function is given, you have to write the class definitions and implementations. For example, for the association example, which is also already done in lecture 20, you can also refer that. You have to write the definitions and the implementation of the customer classes and the credit card class. Customer class and the credit card class, and you should have a driver, for example, customer driver or customer client .cpp. For problem 2, the aggregation example, car and tires, again car.h car.cpp, tire.h tire.cpp, and you should have a car driver, for example, .cpp, or the car client.cpp as a driver file. Similarly, for parts problem 3, uh, for the car and engine example, you have to submit all these 5 files: car.cpp, car.h, and engine.h, engine.cpp, and the car driver file. Problem 4. Alright, so now you must have been familiar with these relationships, association, aggregation, and composition. Try to find out real world examples of these and make class diagrams of these, and then write simple basic codes, and which should include some message passing like function calls between each of these classes. Okay, so find out 5 real examples. Okay, so this is you have to do this as well, and try to not to discuss this. Try to do this individually. Your example should not match with anyone else's examples. And round 5 is the tic-tac-toe game. This problem was initially already given to you in class. So again, you have to design this, and this example might be using more than one relationship. There might be an association as well. There might be aggregation, composition. So use your imagination. Use the concept which we discuss in this lab and in the classes, and then first draw the class diagram. Then you can always discuss. For any queries, you can always post on Piazza. So we'll be available. The course staff will be available. So best of luck. The deadline for the submission would be posted on Piazza. So thank you. So see you tomorrow. Take care.